Hello friends, I warmly welcome you all to my YouTube channel, Design and Numbers. So on today's video, we will be looking into one of the basic knowledge in physics. We will be understanding briefly what is motion, and then we will extend into distance, displacement, speed and velocity, that is as a result of a body being in motion. So let's move straight to understanding what is motion. So what is motion? Motion can be defined as the concept that describes how a body changes its position within a given surrounding with respect to time. Yes, how a body changes its position. It can also be a change in speed. All this is known as motion. So let's assume there is a body standing at point A and an external force was exerted on this body that made it change its position down to point B. We say that this body is in motion. There is a linear motion which discusses how a body moves in a straight path. There is a circular motion that discusses how a body changes its position in a circular path within a fixed axis. That is known as a circular motion. There is an oscillatory motion that discusses how a body moves back and forth only, that is to and fro. Now, there is also a random motion that discusses how a body moves freely without a given direction. So, let's look over into linear motion, which is talking about a body changing its position in a straight path. Let's talk about distance. So, what is distance? I know most of you might be familiar with the word distance. Now, distance is said to be the changing of a position or the actual length a body has covered while in motion. That is how far a body has gone. So if this body being at point A moved down to point B, how far did this body took from this point to this point tells us what distance is. Or in other words, you can say distance is the actual length of the path covered by a body with respect to time. So if the total length from this point A to point B was of 5 meters as its length, the distance is said to be 5 meters. Now, if this body was pushed further by a force, external force probably, if this body was pushed further to point C and it took another length from point B to point C at 4 meters, so what will be the total distance this body has covered? So delta here means changing a given something. So delta D gives us x1 plus x2. That is the summation of all the given points. So our S1 would be from point A to point B. Our S1. Our S2 will be from point B to point C. So x1 is 5 meters, x2 is 4 meters. That means our total distance is equal to 9 meters. So let's move over to displacement. Since we have understood what distance is, what is displacement? Displacement is defined as the distance traveled but with a specific direction. So displacement tells us the direction where this body was being, or where this body covered its given length. So let's state that a body at point A was pushed down to point B, and here is its initial position, here is its final position. So the total length this body was being moved was 5 meters. What is its displacement? delta x, which is gives us x final minus x initial. So what was our x final? Our x final is at point B, which is 5 meters. Our x initial is 0 meters, which is point A, because it was at rest here. Remember, there was no motion at point A before a force now exerted on this object for motion to occur down to point B. So our S initial is 0. Now in calculating it, X final give us 5, X initial, which is 0, 5 minus 0, our total distance, or the displacement, sorry, our displacement is equal to 5 meters. So if we want to actually state the direction which this body traveled to from point A to point B, we will actually say that it moves 5 meters east. So using our coordinate point, here is our north, south, east, and west. And our horizontal line is the x-axis, and east gives us, from the initial point to this point, gives us our positive x. Here gives us, the left hand side gives us our negative x, downside gives us our negative y, the upper side gives us our positive y. So this distance, the displacement which this body traveled, is a positive 5 meters down to east. So it tells us the given direction which this body has gone. Now, what if this body, so let's assume this is the given chart here, point A, point B. This body traveled 5 meters, positive 5 meters. So what if this body decides to come down, move to east direction into the south, and took a distance of minus 8 meters? So what will be the total displacement? Because this axis is our minus y-axis and it is moving down to south, changing its position from east to south. So what will be our total displacement? So total displacement is actually x1 plus x2. That is delta x1 plus delta x2. Change in position at x1, change in position. So what will be our delta x1? So the calculation used in solving, the formula used in solving for displacement is delta x equal to x final minus x initial. So delta x1, which is change in displacement x, that will be x final minus x initial. Let's call it delta x1. Yes. So our final position, which is at point B, is 5. Our initial position is 0. That gives us 5 meters. So delta x2, that is solving for delta x2, gives us x2 minus x1, because x2 is the final position, x1 is now the initial position it started. So that gives us our final position, which is s2, is minus 8 minus x initial, that is b. This is the initial point it started at, b, that is 5, and x1 is 5. So minus 8 minus 5 gives us minus 13 meters. Now, substituting down this, we have delta x total, which is delta x1 plus delta x2. That gives us delta x1 is 5 plus delta x2, which is 13. So our final answer is minus 8 meter. So the displacement which this body has undergone is 8 meters. So we have understood that this body moving from this point to this point, from this point and finally at this point, undergone a total displacement of 8 meters. That is -8. Now, what if this given example we are told to find or determine the distance? The distance, which is x delta d equal to x1 plus x2. So now this will be addition or the absolute value of whatever we have. The absolute value of delta x2, that will be 5 plus 8, which gives us 13 meters. So this is the distance. Distance is always positive. Distance doesn't have negative because it is just going straight. It doesn't have any direction that it is turning into. But displacement can turn, go back, front, go up, go down, which tells us where it is heading to. Now let's talk about speed. What is speed? Now, most times you might be in a discussion with your friend and you might be like, I was driving a bicycle, man, and I was driving so fast. Yes, you can call speed as being fast. So, but in a clearer sense, what is speed? Speed is being defined as the rate by which an object changes its distance. Yes. So, looking at this given example, how fast this object moves from this point to this point is defining as telling us what exactly speed is. So how fast is a given object changing its position? How fast is it? Now, speed and distance are in relation because they are under the same quantity. They are scalar quantities. And what is scalar quantities? Scalar quantities are all those quantities that only have magnitude. That is a beginning part and an ending part, or that's the length, but doesn't have direction. Yes, scalar quantities has only magnitude, but no given direction, and it is always positive. So talking about speed, we always see this associated with speed as meters per second. That is the SI unit of speed. So most times you might hear of 20 meters per second, 30 meters per second, and so on. So what exactly is this telling us? So let's give that we have time, we have distance, and at 0 seconds, a given object is still at a zero distance. No distance has been covered. Now at 1 seconds, if a given object is moving at a speed of 20 meters per second, it tells us that in every seconds this object has covered a distance of 20 meters. So at 1 seconds, the object has covered 20 meters. At 2 seconds, the object has covered additional 20 meters, which is 40 meters, and so on. So speed has a given formula with also distance. So let me use the formula for distance to obtain the formula for speed. Distance is equal to speed multiplied by time. Or you can also say distance is defined as the average speed by time. So V is equal to speed, T is equal to the time, D is equal to distance. Now we want to find speed, that is V. So we will make V the subject of formula by dividing this with T. T will cancel T. We are now left with D all over T. So taking it down to this part, we now have d all over t. That is the formula for speed. So let's assume that a given body traveled a distance of 20 meters in 4 seconds. So this given body traveled a distance of 20 meters in 4 seconds. What speed was this body moving? So bringing down this formula, we have v, which is our speed. Our d gives us 20, and our time, the time frame that this given body traveled this particular distance was 4. So our v would be equal to 5 meters per second. So what if a body now travels from point A to point B, cover the distance of 4 meters in 2 seconds, and from point B to point C, cover another distance of 4 meters in 2 seconds. Now at what speed did this body move from point A to point C? So this explains what is called an average speed. What is average speed? Average speed average speed is equal to the total distance all over the total time. The total distance divided by the total time gives us our average speed. So what is our total distance here for this? So our average speed, that would be total distance is point A to point B plus point B to point C, which is 8 meters, divided by our total time gives us 4 seconds. So our V would be 2 meters per second. So this is the average speed by which this body is moving. Now let's talk about velocity. What is velocity? Velocity defines the rate by which an object changes its position but with a specific direction. Or you can say the rate of change of displacement with time. So velocity is related to displacement because it tells us the direction which how fast a body is changing its position to a given direction. Now, velocity and displacement are vector quantities. Vector quantities are all those quantities that has both magnitude and direction. Vector quantities can be negative or positive. Scalar quantities are always positive and not negative. So let's look into velocity. Velocity, which is denoted as v also, shares the same formula with speed, that is d all over t. But for velocity is equal to x all over t. X here stands for displacement. So if a given body was displaced, so if a given body undergone a displacement of 80 meters in 4 seconds, calculate its velocity. Displacement, which is 80, divided by time, which is 4 seconds. So that will be, our velocity will be equal to 20 meters per seconds. So 20 meters per second is our velocity. So it tells us how fast this vehicle is moving, or this given body is moving. So we have also an average velocity. So an average velocity is the total displacement all over the total time undergone by a given body. So let's see one example that would explain also the average velocity, the total displacement of a given body, the total distance. So if a vehicle moves, let's call this point A, point B. So if this vehicle moves from point A down to point B and covered a distance of 0.5 kilometer and move back forth to pick up something down to point A, which is also 0.5 kilometer, and moves forward again and covered a distance of 1.0 kilometer and moves back forth at point, okay, let's call here point C, and move down to point D and covered a distance of 1.75 kilometer. So we have how many movements here? 1, 2, 3, 4. And east, west, east, west. Positive, negative, positive, negative. So let's find the displacement. Let's find the total displacement total displacement let's also find the average velocity, the total distance. So let's find the total displacement on this given movement that has been occurred by this given body, the average velocity, because this is actually a displacement that occurred, and also the total distance. So solution, the total displacement here, referencing back to our initial formula, we have delta x as displacement, which is x final minus x initial, then total x total, which is delta x1 plus delta x2. So what is our delta x1 and delta x2? Though we have 4 given points here. So our delta x1 will be point A to point B. Our delta x2 will be back from point B to point A. Our delta x3 will be point A to point C, and our delta x4 will be point C to point D. So let's move over. Delta x1, which is equal to x final minus x initial, that is 0.5, which is our x final, 0.5 minus 0. That leaves us with 0.5, a positive 0.5. Now, our delta x2, that is x2 minus x1, x2 minus x1, which is equal to 0 minus 0.5. So why is our x2 0? Now look at this point. From point A to point B is 0.5. So here is initial, here is final. Now from point B to point A took another 0.5. So here was initial and here was final. So the final movement, which is 0, that is, here is our 0. From point B went back to 0. That is the initial starting. Now here is also 0.5. So that's why x2, which is the final position this body went as it went back to point A, which is 0. Then initial, where it started, this body was standing at 0.5. So which gives us negative 0.5. So our delta x3, that gives us x3 minus x2. x3 is our final, x2 is our initial. So that will be 1.0, which is from this point to this point, point C. 1.0 minus, what is our x2? Our delta x2, that is minus 0.5 minus 0.5, which gives us minus minus plus, which gives us 1.5. So our delta x4, that is x4 subtracted by x3. Our delta x4, which is delta x4 subtracted by x3. So our x4, which is 1.7. Yes. So our x4, our delta x4 subtracted by x3. So now let's look at this. This body started from point C again and moved down to point D. Now, from point C to the initial, which is point A, let's call it from point C to point A, clears this 1.0 kilometer. Now, it continues its journey down to the negative x-axis, which is minus 0.75. So, our x4 gives us minus 0.75 subtracted by, let me close all this. So subtracted by our x3. What is our x3? That is 1.5. So this leaves us with minus 2.25. So this leaves us with minus 2.25. Now we have calculated all the 4 given displacements. So our delta x total, which is equal to x total, which is x1 plus x2 plus x3 plus x4, because we have 4 different given displacements. So our x1 here, which is 0.5 minus 0.5 plus 1.5 minus 2.25. So that leaves us with a displacement of minus 0.75. So we have gotten the displacement of this given movement, that, or this change in position that happened, this given displacement. So now let's look at the average velocity. What is the average velocity? Solving for second one. The average velocity from the equation, from the formula, is equal to total displacement all over the total time. So if each movement was done in 2 seconds, so we have 2 seconds, 4 seconds, 6 seconds, and 8 seconds. So each individual point from each point to each point was occurred in 2 seconds. So our total time is 8 seconds. Now, the average velocity here gives us our average velocity, because average velocity is given as this symbol, gives us our total displacement, which is minus 0.75 kilometer all over the total time, which is 8 seconds. Now, because this is kilometer and this is seconds, we have to convert this to meters. So converting that to meters, that will be equal to minus 0.75 multiplied by 1000 divided by 8. So that leaves us with minus 750 meters divided by 8. So our average velocity is equal to, let's check that, our average velocity will be equal to minus 750 divided by 8. That will be minus 93.7 meter per seconds. So you see, with our initial explanation, velocity could be either negative or positive, but speed is always positive. Velocity being negative is because it's associated with displacement. It has a given direction. So now let's answer the final question, which is looking for the total distance. So the total distance, so the total distance so the total distance is equal to the summation of all the individual magnitudes. The individual magnitudes from each point to each point, each point to each point, each point to each point. That's the total displacement. So from point A to point B gives us 0.5, plus from point B to point A is another 0.5. From point A to point C is 1.0. Then from point C to point D gives us 1.75. So that leaves us as our total displacement 0.5 and 0.5, 1.0. This leaves us with 3.75 kilometer. So we have actually calculated this. So if you really understood and loved what you have really watched, please kindly click on the subscription button, and also like and comment. Drop your comments on the comment section. Thanks for watching.